Today we're going through the AQA GCSE Maths Higher Tier Calculator Paper 2 from summer 2023. I recommend you have a go at it on your own first. The question paper and the mark scheme are in the description, and then you can watch along to see how you've got on. Let's get straight into it. Question number 1. Write this ratio 30 to 12 in the form n to 1. This just means I need 1 on the right hand side. What have I divided by on the right hand side to get to 1? Divided by 12 there, and I need to divide by 12 there. So 30 divided by 12 is 2.5. So the answer is 2.52. Question 2. 4 consecutive triangular numbers are 6, 10, 15 and 21. Consecutive just means that they're next to each other. The first two are going up by 4. The next pair are going up by 5. Next are going up by 6. We just need the next one, so add in 7. 7 add 21 is 28. Question 3. Write down the reciprocal of 4 over 7. So reciprocal just means I need to flip it, or what number is this multiplying by that would equal to 1. So if I flip it, it would give me 7 over 4, and if I multiplied these together, that would give me 1. Question 4. The price of a toy increases by 12.5% to £19.53. We need to work out the original price of the toy. The original price of the toy was 100%, and it increases by 12.5%. So the total new percentage is 112.5%. I'm going to convert this into a decimal, which is 1.125. I just need to divide it by 100. So this tells me that 1.125x is equal to £19.53. So to get x on its own, I just need to divide by 1.125 on both sides. So it's 19.53 divided by 1.125, which gives me an answer of £17.36. Question 5. Jess saves 2p, 5p and 10p coins. She has 45 10p coins. Let's just work out the total of those. So 45 times 0.10 would give me £4.50. She has 8 times as many 2p coins as 10p coins. So if I multiply this by 8, that will tell me how many 2p coins there are. So 45 times by 8. I can double this 3 times, so 90, 180 and 360. So I've got 362p coins. Let's just work out the total of those. So 360 times by 0.02, which is £7.20. And we know she's got £17.70 in total. We need to work out the total value of the 2p coins to the total value of the 5p coins. We've already done the 2p's and the 10p's. We need to find out how many 5p's there are. Let's work out the total of those, and we'll take it away from £17.70. So £17.70, take away £4.50, take away the £7.20, and this will tell me the value of the 5p coins. So £17.70, take away 4.5, take away 7.2, which gives me 6. The total value of the 5p coins is £6. So in pence, that is 600 pence. And the value of the 2p coins is 720p. I can cancel both of these down by dividing by 10 on both sides. Let's get rid of those zeros. So 72 to 60. And both of these divide by 12. So 72 divided by 12 is 6. 60 divided by 12 is 5. Question number 6. Part of a regular polygon is shown. Polygon just means many angles, or it's just a shape. Assume that the polygon is an octagon. So octagon, same as octopus, so it has 8 sides, 8 legs on an octopus. Work out the size of an exterior angle. The formula that we need to know here is each exterior angle is equal to 360 divided by n. And here n is the number of sides. So 360 divided by 8, which gives me 45. 45 degrees. Part B, the polygon has more sides than the octagon. What does this mean about the size of an exterior angle? Let's just say we have a 10-sided shape, or a decagon, and we were using this formula again, 360 divided by 10. This time it would give me 36. Because I'm dividing by a larger number, the answer is going to be smaller because I'm sharing it between more parts. So the answer would be, it is less than the answer to part A. Question 7, we've got a game. An ordinary fair 6-sided dice is rolled, and the fair spinner shown is spun. So each of these probabilities is going to be equal. Score is the dice number substituted into the spinner expression. Complete the table below. So all it's saying is they roll a dice and they get 1, 2, 3, 4, 5 and 6, and then afterwards they spin this spinner and these are the results of it. We just need to substitute these into here. 1 into 2x, 2 times by 1 is 2, 2 into 2x, 2 times 2 is 4, 3 into 2x, 2 times 3 is 6, and you can see these are going up in 2s, 2, 4, 6, 8, 10, 12. The next one, 3x, it's just going to be my 3 times table, so 3, 6, 9, 12, 15, 18. The next one, x squared, so 1 squared is 1, 2 squared is 4. These are just going to be my square numbers, 16, 25, and 36. Part B. A player wins the game if their score is 10 or more. Work out the probability that they win the game. So we need to find all the cases where it's 10 or more and the total amount of cases. So that's 10 and more, that would be 10 and more, and all of these will be 10 and more. All of these are smaller than 10, so we don't include them. You have 3, 6, 8, so that's 8 out of a possible. There's 6 in the first row, 12, 18, so 8 out of 18 possibilities. With probabilities, you don't have to simplify them, you still get the full marks for that, but we'll just simplify it anyway. Part C, the game is played 711 times. Estimate the number of games that are won. The formula that we're using here is expected outcome is equal to the probability multiplied by the number of trials. Number of trials just means how many times do they actually do this thing. So here, the probability of winning is 4/9, and we're multiplying it by 711, which is how many times they do it. So 4/9 multiplied by 711, which gives me 316. So we would expect them to win it about 316 times. Question 8, we've got this expression here and this funny looking equals, which just means identical to the other side. So this side is identical to that side. We're trying to work out the values of a and b. Let's first expand this bracket and clean this left hand side up. So we're doing a multiplied by x squared, so that gives me ax squared. Negative 3 times x squared is negative 3x squared, and then we're left with a plus 2b. And that's equal to 5x squared plus 12. We're going to do something called equating coefficients. So I can see there's an x squared here, and the number before the x squared is 5. And on the left hand side, I've got this, that's an x squared, and this, that's an x squared. So that is a, and that is minus 3. So a take away 3 is equal to 5. Add 3 to both sides, a is equal to 8. So I've done a, I need to do b now. So 2b is going to be equal to that 12. 2b is equal to 12. Divide by 2 on both sides, b is equal to 6. Question 9, a and b are points on a centimetre grid. A, B, C, D is a parallelogram. So right now we have a and b, but we don't have c and d. We're going to need to draw them on. Parallelograms are just squash rectangles where we have 2 pairs of equal sides, and both of those would be parallel to each other. AD and BC are horizontal and each has length 5 centimeters. If you sometimes forget which way is horizontal, if you think about the word horizon, or when you're at the beach, you would see the sun and the sand and it would go from left to right. Vertical would be up and down. Each has length 5 centimeters, so it could go right that way or it could go left that way. Let's just draw those parallelograms on first. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And now I'm just going to connect all of those so that we can see the 2 parallelograms that we have. So we're just connecting those 2 lines, those up. And now we have 2 pairs of parallelograms, and these 2 would be congruent to each other. They're exactly the same as each other. Diagonals of A, B, C, D cross at E. If I draw the diagonals on, I'll see the points of intersection, and those points would be E. So one of them, that would be E, would be negative 1, 6. And the other one, if I join the diagonals up, better to do this with a ruler, but the point of intersection would be 4, 6. So you could have 2 possible coordinates of E, negative 1, 6 and 4, 6. Question 10, write down the translation vector that maps shape A onto shape B. So I'm going from A to B. You always choose the same point, and I'm going to see how this corner has moved to that. That has moved 1, 2, 3, 4 to the right, and then it's moved 1, 2, 3 down. We write translation vectors like this in the form x, y, where this is the x direction and this is the y direction. So that's left and right, and that's up and down. For right, that would be positive 4. And because it's going down this time, this would be negative 3. So the column vector is 4, negative 3. Question 11. A ball is a hemisphere with radius 12 centimeters. Hemisphere just means half of a sphere, and we've been given the formula for volume of a sphere. Let's first work out the volume of this hemisphere because it will be useful. So volume of the hemisphere is going to be 4/3 pi r cubed. Here 12 is the radius, so times by 12 cubed. And this will be divided by 2 because we've only got half of the sphere. So 4/3 times by pi times by 12 cubed, and this is being divided by 2. So we get 1152 pi. 152 pi. I'll keep it in terms of pi until later on if we need to change it. Water is poured into the bowl at a rate of 325 centimeters cubed per second for 8 seconds. Let's find out how much water is being poured into that bowl. So that's 325 multiplied by 8. 325 times 8, which is 2,600. Does the water fill more than 70% of the bowl? Show you working. We find out what percentage has been filled from the bowl by taking the 2,600 divided by 1,152 pi, and we can see if it gives us an answer bigger or smaller than 0.7 or not. So 2,600 divided by 1,152 pi, which is equal to 0.7184, equals 0.7184. And this is the same, if I times this by 100, that gives me 71.84%. So this is more than 70% of the bowl. So yes, it fills more than 70%. It fills more than... It fills 71.84%. Question 12, show that these two rectangles are similar. Similar just means that we've multiplied everything from the first rectangle to the second rectangle by the same amount. So we can prove that it's been multiplied by the same amount. That means that they're similar. So we'll do 8 divided by 5 first, which gives us 8/5 or 1.6. So that's times by 1.6. And the other side, 19.2 divided by 12, that also gives us 1.6. So they've both been multiplied by 1.6. That means the scale factor is 1.6, and therefore they are similar. Question 13, a factory packs X boxes of tea bags per hour, and each box contains 80 tea bags. Because there's 80 tea bags in each box, they are packing 80x tea bags per hour. Show that the factory packs 4x over 3 tea bags per minute. This is per hour. If we divide this by 60, it should give us 4x over 3. 80 divided by 60, which gives us 4/3, which is the same as 4/3 x, and you can write that as 4x over 3. Question 14, a company has some employees and this table shows us their hourly rates. So 66 people have an hourly rate that is equal to 10 or less than 14. Statement A says over 30% of employees have an hourly rate that is more than £17. Show working that supports statement A. So we're trying to prove that more than 30% earn more than £17. If we look at the second row, we can see that 32 people make £14 or more and less than 20. But if all of these people earn more than 17, so for example, they all earn £18, we'll just say all of them earn £18, would this amount of people be more than 30%? We have 32 plus 15 plus 10, so 32 add 25, which is 57, and that 57 is out of 123. 57 over 123, which gives me 0.4634. 0.4634. If I multiply that by 100, I get 46.34%. Shows that statement A could be true because 46.3% is more than 30%. Part B, why might statement A not be true? So we assumed that everyone in that second row had £18 or more. We could assume that they all earn less than £17, so they could also earn £16 each. So we have 32 add 66. 32 add 66 over 123 is equal to, that'd be 0.7967, which is the same as 79.67%. So if we chose that people earned less than £17, we could have way more than 30% earning less than that. Part C, work out an estimate of the mean to support statement B says the average hourly rate of pay is more than £20. Whenever you're working out estimated mean for grouped frequency tables, we need to add in two columns. The first column is going to be my midpoint, and we're going to take a look at this class interval and find where is the middle of those two. So the middle of those two, 10 and 14, is 12. If you're not sure where the middle is, you can find the mean of those two numbers. So 10 and 14 is 24, and there's two numbers, so we divide it by 2. That's if you struggle with finding out where the middle is. Between 14 and 20, the middle number is 17. Between 20 and 40 is 30, and between 40 and 100 would be 70. So we've got all of our midpoints. Then we need to add another column in called our fx column. We're going to multiply these two numbers by each other, these two numbers by each other. So 66 times by 12, and then 32 times 17, and 15 times 30, and 792544, 792544, 450, and 700. Whenever we work out our mean, we take the total amount and we divide it by the frequency. So here the total amount will be this number, and the total frequency is already given to us. So let's add up all of these numbers. I've got 792 plus 544 plus 450 plus 700. That gives me 2486. 2486. And we need to divide it by 123. Before I get my answer, I'm just going to look at these and think, where would an appropriate mean be? There's quite a few people in this first row and in this second row, so I would estimate the mean to be somewhere about here. So it should be between 14 and I would say 30. So 2486 divided by 123, which gives me an answer of 20.2114. That's right, 2486 divided by 123 is equal to 20.21. The reason why it's an estimated mean is because we don't know the actual hourly rates. We're just estimating what they could be. We're using the midpoints. So like we did in question A, all of the people in this first group might actually earn £10, and all of the people in the second group might earn £14. So that would make the actual mean a lot lower. That's why it's called an estimated mean. Part D, why is the mean not the best average to represent this data? Part D, why is the mean not the best average to represent the data? In the previous question, we worked out the mean was £20.21, but we also saw in the part before that, that almost 80% could be below £20. So if way more than half of your data is below £20, that means it might not be the best representation for your data. Better representation for this data would probably be the median, which would be in this row. So the people earning between £10 and £14 are the most common, and the median would fall there because half of 123 is 61.5, so it would be in that first row. The people that are earning more than £20 are heavily skewing this data. So those people that are earning high salaries, which is not that many, are heavily skewing the data to increase that mean. So the way we could write this is the median is a better representation. And one reason for that is because the higher earners are skewing the data. Higher earners are skewing the data. Question 15, expand these double brackets. Whenever I'm expanding double brackets, I'm multiplying everything in the first bracket by everything in the second bracket. And the order that I like to multiply things are, I look at the signs first, so whether they're positive or negative, and then the coefficients, what numbers are the variables being multiplied by, and then the variables themselves. Variables just means the letters, and then the powers finally. So I've got 1 lots of x squared multiplied by 2x. 1 times 2 is 2. X squared times by x. So whenever you're multiplying and you have the same base, you just add the powers. So there's an invisible 1 there. So 2 add 1 is 3. So 2x cubed. Then we've got x squared times 5y. 1 times by 5 is 5. X squared times by y is just going to be x squared y. Next, we need to look at this second term, this negative 9xy. So it's negative times a positive, so negative. 9 times 2 is 18. X times x is x squared. And there's going to be a y at the end. Then we're doing negative 9 times by positive 5, so it's going to be negative 45. X, there's no x there, so there'll be an x here. And there's y times y, which is y squared. Whenever you've done something like this, always just look, can we clean it up a little bit? So I can see that these two terms here have x squared y in them. This has x squared y there, and this has x squared y, so we can combine these two. The coefficient of this one is 5, and the coefficient of this one is minus 18. So 5 take away 18 is negative 13. So finally, we've got 2x cubed. This will combine to make negative 13x squared y, and then we're left with minus 45xy squared. That'd be your final answer. Question 16, line A has equation y equals ax minus 1. The general form for equation of a line is y equals mx plus c, where m is the gradient and c is the y-intercept. This is just saying, where does it cross the y-axis? The gradient is saying how steep the line is. For this first line, m would be a, and the point where it crosses the y-axis is going to be 0, negative 1. So c is negative 1. It passes through the point 7, 13. So let's just work out this equation of this line. We have a few pieces of information, so we can substitute those in now. This coordinate is going to be my x and my y value, and we're trying to find out what a or m is. So let's substitute this into my equation of a line formula. Y is 13. That's equal to, we don't know what that is, so we'll leave it as a. X is 7, so I'll write it as 7a, and c is negative 1. A is being multiplied by the 7, and then we're taking away 1. So we need to add 1 to both sides. So we've got 13 add 1, 14 is equal to 7a. Divide by 7 on both sides, which leaves us with 2 is equal to a. We can write the equation of that first line. Y is equal to, the gradient is 2x, and it goes through minus 1 on the y-axis. So y equals 2x minus 1. Line B has equation 5y minus 3x equals 4, and we need to show line A has a greater gradient than line B. So line B, it isn't in the form y equals mx plus c. It's in a different form. So we're trying to make it so that y is the subject. We want this y on its own. So 5y minus 3x equals 4. Because right now, we can't see what the gradient is. The y, it's being multiplied by the 5, and then we're taking away 3x. So we'll get rid of this minus 3x first, because it's the last thing that's happening. And we'll do that to both sides. The opposite of minus 3x is add 3x. So add 3x to the left-hand side leaves us with 5y is equal to 3x plus 4. And then we need to divide by 5 to get y on its own. So that leaves us with y is equal to 3 over 5x plus 4 over 5. I could write it all over 5, but it's better just to have them separate so we can see what the coefficient of the x is. The gradient here is 3/5 because the coefficient of the x is 3/5. And now I can compare these two gradients. The gradient of line A is greater than gradient of line B because 2 is greater than 3/5. Question 17, work out the size of angle X. If we take a look at where X is, it's in this triangle ABC, which has a right angle in it. So that means we're going to be using trig. We only have one piece of information in this triangle, which is this length, so we need another piece of information for us to be able to work out this angle. Let's concentrate on this triangle here, where we've got an angle and a side. So I'll label my sides up first. So the side opposite the right angle is the hypotenuse. The side opposite the angle is just opposite. The side that's left over is the adjacent. And we always want to concentrate on the side that we have and the side that we're trying to find. So would it be any use finding O? Because we want to try and find information for this triangle. So let's find out A. So if I look at SOHCAHTOA, which of these have the letters A and H in? So that would be cos. So this is saying cos of theta, cos of 37 is equal to adjacent over hypotenuse. Adjacent is the one that we don't know, so that would be x, and hypotenuse is 4. And we can rearrange this equation, times in by 4 on both sides, so we get 4 cos 37 is equal to x, 3.1945. So x equals 3.1945, 3.1945. Now we have two sides in this triangle. Let's figure out what those are. I'm going to rub this out just because it might make it a little bit confusing. So this angle, the side opposite to that angle is this 3.1945, which we just worked out. So that's going to be my opposite now. And the side that's opposite the right angle, the longest side, is my hypotenuse, and that's my adjacent side. So here we have H and we have O. So which of these have H and O? So we're going to be using sine this time. This time we don't know the angle, so we've got sine of x is equal to the opposite over the hypotenuse. So opposite is 3.1945 and the hypotenuse is 9.3. To move this sine over to the other side, I need to take the inverse sine of both sides. So that leaves me with x is equal to the inverse sine of 3.1945 over 9.3. So we're working out this angle. Let's just type this into the calculator. So we're doing shift sine first, and that would be 3.1945 over 9.3, which gives us 20.08. So x is 20.090 rounded to 3 decimal places. X is 20.090 to 3 decimal places. And the units for that, because we're looking at an angle, that'll be in degrees. Question 18. Rearrange this equation to make x the subject. So right now I can see I've got x on the top of the fraction and x on the bottom of the fraction. I want to try and get all the x's onto one line. So let's move this x over to the other side first. So we'll multiply both sides by x. So x times by y gives me xy, and then we're just left with x plus 8. We're trying to get all of these x's to one side so that we can factorize it out. I'll take away this x from both sides. So xy, take away x is equal to 8. And now I'm going to pull out the x, so I'm factorizing. So x outside the bracket. What multiplies by x to give me xy is just going to be y. What multiplies by x to give me negative x minus 1. And you could expand that bracket just to check it. Is equal to 8. Final step, I just need to divide by y minus 1. Right now, there's an invisible time sign between these two. So if I divide by all of y minus 1, it'll move this over. So divide by y minus 1. That leaves me with x is equal to 8 over y minus 1. So x has been made the subject. Question 19. Here are the first 4 terms of a quadratic sequence, and we're trying to find out what the nth term of this quadratic sequence is. The first step that we need to do is find the second difference. Let's find out the first difference first. So between 3 and 20 is 17. Between 20 and 47 is 27. Between 47 and 84, so that's 34 plus 3, which is 37. So the first differences are all going up by the same amount. So that's going up by 10, and that's going up by 10. And whatever the value of the second difference, I divide that by 2. So 10 divided by 2 is equal to 5. This is telling me that the sequence is going to start with 5n squared. So I want to write out what this sequence is and see how it relates to my original sequence. To write out the sequence for 5n squared, a little trick is if you know your square numbers, you can write them out first. 1, 4, 9, 16, and that'll be enough because we only have 4 terms. And we'll multiply these by 5. So 1 times 5 is 5, 4 times 5 is 20, 9 times 5 is 45, 16 times 5 is 80. And now we want to look, what is the difference between 5n squared and the original sequence? So from 5 to get to 3, we've taken away 2. From 20 to get to 20, we've added 0. From 45 to 47, we've added 2, and then that one is add 4. So here we have a linear nth term sequence, so we need to find out what that is and combine it with that one. This sequence is going up in 2s, so that would be 2n, and I write out my 2 times table. And how has the 2n sequence differed from the original sequence here? So here we've taken away 4, here we've taken away 4, here we've taken away 4. So it's always 2n take away 4. Final step, I just need to combine these two things. So final answer is 5n squared plus 2n take away 4. If you wanted to check this using the fourth term, substitute n equals 4 because this is in the fourth position. And when you substitute 4 into this, you should get 84. Question 20, P, Q, and R are points on a circle, and S is a point inside triangle PQR. Assume that S is the center of the circle, and we need to work out the size of angle X. I can see that we're going to be using one of our circle theorems here, that angle at the center is twice angle at the circumference. The way that you can remember it is if you think about cities, the population at the center is going to be more than the population at the edge. So all we're doing is 130 divided by 2, which would give me 65 degrees. Part B. In fact, the center of the circle is on PS but not at S. What does this mean about the size of angle X? Is it the same, greater than, smaller than, or impossible? It tells us that the center is not at S, it's somewhere along that line PS. So it could be, for example, over here. And if we draw a triangle at P, the new S and R, what's happened to the angles inside that triangle? This angle has stayed the same. This angle at our new SRP has gone a little bit smaller, so that means that this will have got a little bit bigger than 130. As this has become larger, this angle will also become larger. So the answer for this would be it is greater than the answer to part A. Question 20C. For a different circle, AB is a tangent to A. C and D are on the circumference of the circle, and AC equals CD. So we can see a few things going on. Let's read what they're going to ask us. Simon's worked out the size of angle Y using this method. So he's found ADC equals 70, A to D to C is 70, and the reason that he's used is alternate segment theorem. So that is alternate to that one. That's incorrect, because if we take a look at alternate segment theorem, we've got these pair of lines, and the other pair of lines that we need to consider are these two. So this 70 will actually be alternate to this 70. So that means that first line was wrong. His answer, he uses angles in an isosceles triangle. So you can see isosceles triangle, but because he's got that first one wrong, that would make I wrong. These two will be equal to each other. So all we do is 110 divided by 2, which gives me 55. Y should actually be 55. Y equals 55. If we want to prove Simon's method is wrong, he said ADC equals 70, but we know BAD is alternate, not to ADC, but to ACD. Question 21. Morgana decides to put £500 into an account that pays compound interest. This just means that the interest will accrue on the previous interest earned. She wants to have at least £560 in the account after 3 years. Work out to one decimal place the minimum annual interest she needs. Let's look at the formula for compound interest. So we use the original amount. Here the original amount will be 500. And we multiply this by the decimal multiplier. And that will be raised to the amount of repetitions. Here the amount of repetitions will be 3 because it's 3 years. So original amount is 500. We're multiplying this by something. So because it's an increase, it's going to be 1 plus something. So we'll call that number x. And that will be raised to the power of 3 because there's 3 years. And all of this will equal, or we want it to equal, £560. So we're trying to find out what this decimal is, what this percentage is that she wants every year. So let's simplify this equation. I'm multiplying by 500 on the left. So if I divide by 500 on both sides, I'm left with 1 plus x in brackets to the power of 3 equals 560 divided by 500. I can simplify this, so that becomes 56 over 50, or 28 over 25. I've got this left-hand side all being cubed, so I can cube root both sides. Now I'm left with 1 plus x is equal to the cube root of 28 over 25. To get x on its own, I need to take away this 1. So x is equal to the cube root of 28 over 25, and then on the outside of that, we'll take away 1. That will give me the decimal, or the percentage, that it'll be increasing by every year. So let's type that in. So the cube root of 28 over 25, and we need to take away 1 from that. So that gives an answer of 0.0385. So x is equal to 0.0385. We need to remember that this is a decimal. We want it as a percentage. So we'll times that by 100, and that will move the decimal place 2 places to 3.85%. Now the way that you could check this answer, you could substitute 3.0385 back into here, and you should get 560. Final answer is 3.85%. That's the percentage that she's looking to earn every single year. Question 22. Approximate value of a root of an equation can be found using the iterative formula. Iterative just means I'm going to repeat this every time, and every time I repeat it, I'll get closer and closer to the actual answer. The starting value of x1 is 4. So x1 is 4. We need to find out the values of x2 and x3. This is 2. I'm substituting in 4, which got the cube root of 5 multiplied by 4 in bracket squared minus 2 multiplied by 4, take away 3. Let's type that out. So the root of 5 times by 4 in bracket squared, take away 2 times by 4, take away 3. That's equal to 4.1016, equals 4.1016. Then for x3, instead of typing in 4 and 4 again here, I'm just going to type in ands, and then I can find later ones if I need it. So third root of 5 multiplied by the answer squared, take away 2 lots of the answer, minus 3. And that gives me 4.1776. So 4.1776. Part B, by continuing the iteration, show that the value of x is more than 4.25. So because I've already used the answer function here, if I press in equals again, I get the next value. So x4 is 4.234, x4 equals 4.2341. And then if I press it again, I get x is equal to 4.2758, 4.2758. So x5. And that's showing me that the value of x is more than 4.25. And if I repeated this many more times, I would get an answer closer and closer to the actual value of x. Question 23, here are a set of cards. In a game, a player has two options. We can pick two cards from set A, or we can pick one card from set B and pick one card from set C. Cards are picked at random, and the player wins if the total of their two cards is exactly 10. Which option gives a better chance of winning, option 1 or option 2? So let's take a look at option 1 first. The way we can win is finding two cards that are exactly 10. So what are some ways that we can make 10 from set A? If I look for two numbers that add up to make 10, if I have 1, I don't have a 9, so that doesn't make 10. 3, there's no 7, so that doesn't make 10. I have 5s, so I could use that. 6, there's no 4. 8, there's no 2. So we're going to be using these 5s. If I can only pick two cards, I can either pick 5 for my first pick, and then I can pick 5 for the second pick. So we're trying to find the probability of getting a 5 first and then a 5 second. For the first pick, I have 3 5s, so 3 out of 1, 2, 3, 4, 5, 6, 7, 8. So that's my first pick. For the second pick, I've taken out one of these 5s. So now I'm left with 2 5s. And now we need to remember there's not 8 cards remaining, there's 7 cards remaining. So it's over 2 7s. 3 times 2 is 6, 8 times 7 is 56, and that would simplify to 3 over 28. So that's option 1 done. Option 2, we pick one card from set B and one card from set C. So 1, there's no 9, 2, there's no 8, 4, there's this 6, 6, there's this 4, 8, there's no 2, 9, there's no 1. So these are two possible combinations we could have. We could have 4 and 6 or 6 and 4. So let's work out the probabilities of both of those. So we'll do probability of getting a 4 and then a 6. So probability of getting this 4 is 1 out of 1, 2, 3, 4, 5, 6, 7. Multiply it by 1 out of 4. So that's 1 out of 28. Then the other way we could get it is this 6 and this 4. So probability of getting this 6 and this 4, I think it's going to be exactly the same. So 1 out of 7 and 1 out of 4 again. So that's equal to 1 out of 7 times 1 out of 4, which is 1 out of 28. I need to add up both of these two together. So 1 over 28 plus 1 over 28 is equal to 2 over 28. And this is nice. I won't simplify it because I can compare it very easily now. Option 1 gives me a probability of 3 over 28, and option 2 gives me a probability of 2 over 28. And the larger of these two numbers is 3 over 28, so option 1 is more likely. The probability of option 1, we're just summarizing our answers here, was 3 over 28. And the probability of option 2 is 2 over 28. So this one is larger than this one. Probability of, we'll just write 0.1 is greater than probability of option 2. Question 24, A equals 65 to the nearest integer and B equals 30 to one significant figure. I can see I'm working with bounds, so before I go on to the rest of the question, I'm going to work out the error intervals for these two. To work out error intervals, I take the original number and I plus and minus the limit of accuracy divided by 2. So for A, the original number is 65. I'm going to plus and minus the limit of accuracy, and that just means what has it been rounded to. This one is to the nearest integer, which is the nearest whole number or the nearest unit. So I'm doing 65 plus or minus 1 divided by 2. So the smaller of those two numbers will be 64.5, and the larger of those two numbers will be 65.5. If I want to write this as an error interval, I know A is somewhere between 64.5 and 65.5. And it could be greater than or equal to 64.5 or anything smaller than 65.5. For B, we've got 30 rounded to one significant figure. So here, this has been rounded to the nearest 10. So the original number is 30. I'm plussing and minus 10 divided by 2, which is the same as 30, take away 5 and add 5. So the smaller of the two will be 25 and the larger of the two will be 35. So writing this as an error interval, that'd be 25 is smaller than or equal to b, which is smaller than 35. So a could be somewhere between these two numbers and b could be somewhere between these two numbers. We want to work out the upper bound for 2a squared minus b squared. So we're trying to maximize the value of this expression. So we want a really large number for this first bit and we want a really small number for the second bit. So for the first bit, I'm going to choose this for my a value, and for the second bit, I'm going to choose this as my b value. So I'm maximizing the value of the expression. Let's substitute these two into this expression. 2 multiplied by 65.5 squared, take away b squared, 25 squared, and this will give me my final answer. 2 times by 65.5 squared, take away 25 squared. That gives me an answer of 7,955.5 equals 7,955.5. Question 25. Show that these two algebraic fractions added together look like this. Whenever I'm adding fractions, I need to make sure I have common denominators. So to find common denominators here, I'm just going to multiply both of these, and that will give me my lowest common multiple. So I'm multiplying this left-hand side by x plus 2, and I'm multiplying this right fraction by x minus 2. So x plus 2 multiplied by x minus 5 for that first bit, plus x plus 5 multiplied by x minus 2. And all of this will be over x minus 2 multiplied by x plus 2. All we need to do now is just combine and simplify. So we're expanding these two brackets. So x times x is x squared. And a trick you can use here, 2 take away 5 is negative 3, so it's negative 3x. And 2 times negative 5 is negative 10. And then for this one, I've got x squared. 5 take away 2 is plus 3, so plus 3x, and 5 times negative 2 is minus 10. And on the bottom, I can see I've got difference of two squares, so it's just going to be x squared. The negative 2x plus 2x cancel each other out, so it's just negative 2 times 2, which is negative 4. And you can see we've got that bit already. We just need to clean this bit up. So I can see I've got x squared here and x squared here, so that'll be 2x squared. Then I've got this minus 3x plus 3x, so they're going to cancel each other out. And then we have a minus 10 minus another 10. So negative 10 take away another 10 is negative 20. That'll be x squared minus 4. That'll be my final answer. Question 26. Here is a sketch of y equals x squared. It's going through the origin and it's a U-shape or a parabola. The minimum point of y equals x squared is at 0, 0. Write down the coordinates of the minimum point of y equals x squared plus 2. So this one is outside of the bracket. If it's inside the bracket, it's affecting the x coordinates. If it's outside the bracket, it's affecting the y coordinates. The new minimum point, because it's been shifted up from 0, 0, it's going to be at 0, 2. Part B, the graph y equals x squared is reflected in the x-axis. Write down the equation of the graph after this transformation. Because it's reflected in the x-axis, we just need to make this x a minus. So it's going to be y is equal to minus x squared. And if you substituted values into here, you would see that the graph would look like this. Part C, y equals x squared is now transformed to give y equals x plus 3 in bracket squared. Describe fully this single transformation. If it's inside the bracket, that means it's affecting the x direction, and it's the opposite of what you're expecting. So we would expect it to move 3 to the right, but it's actually moving 3 to the left. And here we need to write it as a vector. So it's being translated, and because it's moving 3 to the left, it's going to be minus 3, and it's not moving up or down 0. That's the end of the questions for today. If you've enjoyed it, like and subscribe, and you can check out my channel for other papers, including the paper 3 that comes after this paper. I'll see you soon.